All right, so our goal here in this problem, it's one big problem. We've got, looks like 7 different terms up there. Our goal is to simplify each square root individually, and then if we can, we'll add and subtract them. All right, when are we going to be able to add and subtract them? When they are like terms, exactly. So when they're like terms, that means that they're going to have the same, what? What's going to make them like terms if they have the same what? The same square root or the same radicand, right? All right, so what we're going to do is we're going to simplify all 7 of them. Okay, we're going to do what we can with those. And then once we do that, we're going to see which ones have the same square root, see which ones have the same radicand. We'll combine those, and then we'll write out our answer. All right, so first thing we're going to do to simplify is we're going to do factor trees. So we'll do factor tree for every one of these here. And once we do that, after we have the factor trees, what's next? What are we going to do after that? We're going to rewrite it. All right, so next step is to rewrite the problem. I'm going to make it kind of small. Hopefully you can read what I write here. But I'm going to need to make it small because we've got a lot of stuff to write here on this next line. All right, so each square root, I'm going to replace the radicand with the prime factorization for that radicand. So instead of 32, I'm going to have what? Yeah, I think we should have 5 of them, right? So there's 5 2's there. Then the next one, there's something a little bit different about this next term. What do I need to make sure I have with this next one?
With the 3.
Yeah, we need that coefficient, that 3 on the outside. So we've got the 3 on the outside, and then instead of 24, we're going to have
2 times 2 times 3.
Okay. Then we've got a minus, and minus the square root of 45. So instead of 45, we're going to have
3 times 3 times 5.
Alright, and then plus the square root of 6. So instead of 6, we're going to have 2 times 3. Next one, we have another coefficient. Don't forget about that. So we've got the 2 out front. And then for the square root of 80, we're going to have 2 times 2 times 2 times 2 times 5. Then minus the square root of 8. So instead of the 8, what are we going to have? I think that's too many of them, Jayla. How about just 2 times 2 times 2? What? Okay. And then instead of the 25, actually there's 2 different ways we could do the 25. 25 is a perfect square. So we could write it as 5 times 5, which is the way we factored it, or we could write it as 5 squared. I'm going to do it that way. It's just a little bit less work, and just a reminder of how we did it a couple weeks ago when we were doing square roots of perfect squares. All right, now once I have all this rewritten, what's the next thing I'm looking for?
Circling the pairs?
Yeah, we want to circle pairs. All right, so going back to the first one, for the square root of 32, we have a pair of 2's and another pair of 2's. And then over here we have a pair of 2's. And we have a pair of 3's. No pairs in that next one, right? So moving over, we got a pair of 2's and another pair of 2's. And then we have a pair of 2's here. Lots of pairs of 2's, huh? And then for the last one, we have a pair of 5's, but we have it written a little bit differently. What's going to happen here with this one? The square is going to cancel out with the square root. Exactly. All right, so going through, we're going to rewrite again. All right, so after we have all our pairs circled, we're going to do another rewrite. And this time, anything that we have circled is going to go where? It's going to go on the outside of the square root. Okay, so those things that we have circled on the inside, those pairs are squares, and they end up on the outside. So for the first one, what do we get on the outside? 4. So we've got a 2 times 2 is going to give us 4 on the outside, and what's left on the inside? 2. All right, how about the next one? We've got a plus, and then what's going to be on the outside for the next one?
2.
We've got a 2 going out, but what's already out there?
3.
There's already a 3, so it's going to be 2 times 3, which is 6 on the outside. And what's left on the inside?
6.
6, okay. Then we've got a minus. What goes on the outside for that one? 3. And on the inside?
5.
Okay, then we've got a plus. Nothing's going on the outside for this, right? So what do I do with this one?
Just 6.
Yeah, well, it's not just 6, but we need that square root there. So all we do is we multiply it back out. And for this one, since there are no pairs, we're just going to get what we started with up here, which is the square root of 6. All right, then for this one, we've got a 2 times 2. It's going to go out there, but there's already a 2 there. So what do we end up with?
8.
8. So it's going to be plus 8 square root of 5 minus
2.
2 on the outside and 2 on the inside. And then the last one, remember the square and the square root cancel each other out, so that's just going to be minus 5. No square root on that. Okay, when the square root cancels, it's gone. Or if you have everything circled, if you wrote it as 5 times 5 and circled a pair of 5s, that's going to get rid of the square root also. All right, what's the next step? So we're looking for like terms, and when we combine the like terms, we want to write them in order from the smallest radicand to the biggest radicand. Which is going to be the first term here? Yeah, so the number that's by itself with no square root, that's always going to go first. All right, there are no other ones for that negative 5 to combine with, so it's just going to be a negative 5. All right, so that first term is negative 5. All right, what's going to come next? What's the smallest square root that we actually have now? The 2's, right? So let's see what we've got. We've got a 4 square root of 2, and I see a negative 2 square root of 2. So what's 4 square root of 2 minus 2 square root of 2?
A positive.
Positive 2 square root of 2. Okay. Then what? Looks like we have, we got the minus 5 already. We got the square root of 2's already. So yeah, it looks like square root of 5's next. So we've got a negative 3 square root of 5 and a plus 8 square root of 5. So it's negative 3 plus 8. Same thing as 8 minus 3, right? What's 8 minus 3? 5. Is that positive 5 or negative 5? Positive, right? Since the 8 is bigger, there's more positives than negatives. There's a negative. So we're going to get a positive 5 square root of 5. So we've got the square root of 5's done. And the only thing left then is the square root of 6's. So we have a 6 square root of 6 plus the square root of 6. What coefficient can I put here if there isn't one?
1.
Yeah, we can put a 1 in front. So what is 6 square root of 6 plus 1 square root of 6?
7 square root of 6.
And that's everything, right?
Yes.
There are no like terms in here that we can combine.
No.
So that is our final answer. We have it. We have all the like terms combined, and we wrote our answer, the terms, in order from the smallest radicand to the biggest radicand.